This is part 3 of our review of probability. In this lesson, we will work with some tables and talk about the probability of those. So, number 7. The table below shows the winning percentages of 4 athletic teams at Bay High School that are active in league competition. Okay. So we've got boys lacrosse, boys baseball, girls softball, and girls lacrosse. Alright, good to know. All 4 teams are scheduled to play today. The school's athletic director wants to know the probability that at least one team will win today based on the data. She assumes that each team's winning or losing is independent of all other teams' results. Complete parts A through F. Okay, what is the probability that the boys baseball team or boys lacrosse team will win today? Well, let's start by assigning each one of these events a letter, so it will be easier to work with in formulas. So we'll call boys baseball winning event A. Boys lacrosse will be event B. Girls softball event C. Girls lacrosse winning will be event D. So what we're trying to find is the probability that the boys baseball team or boys lacrosse team. So boys baseball, so we're finding the probability of A or B, baseball or lacrosse. Alright, well, we have a formula for this, people, and that's what we're going to have to use. So I'm going to just go with the words. So the probability of A or B is the probability of A plus the probability of B minus the overlap. Okay, so let's start with that. So we're going to find the probability by doing the probability of A plus the probability of B and then minus the probability of A and B. Alright, now two of these things we already know. Probability of A is 60%. You know, if we go by what's happened in the past. So I don't have a lot of room for calculations here, so I'm just going to have to replace things. So probability of A, that's 60%. Probability of B, that's 50%. Okay, so that's going to be 50%. Now we have to subtract the probability of A and B. Now, they did not give us the probability of A and B directly. So what are we going to do? Well, that is a separate formula which we're also going to have to use. This formula holds when the events are independent. Alright, the probability of A and B is the product of the two probabilities. But we can only use this when the two events are independent. Luckily, they said in the problem, she assumes that each team's winning or losing is independent of all other teams' result. So that means we can use this formula. So if I want to find the probability of A and B, all I need to do is multiply the individual probabilities together. So what I need to do then is to multiply 60% times 50%. Okay, that's what's going to give me this. So 60% of course is 0.60 or 0.6 and 50% is 0.50. Or I could have just said 0.5. Now if I put these in the calculator, okay, 0.60 times 0.50, I get 0.3 or 0.30, 30%. Okay, so what I just found was that this is going to be 30%. So if I do 60% plus 50%, then I need to do minus 30%. And that should give me the probability of A or B, which is what they wanted. So 60 plus 50, that's 110%. Minus 30% is 80%. Okay, so I think we'll have to do a similar calculation for a bunch of these. But that's the answer to part A. Now, what's the probability that a boys team will win today? Well, that's the same question we just answered. All right. The probability that a boys team will win, well, that would mean boys baseball or boys lacrosse. And we just calculated that that was 80%. Okay, so moving on to part C. What's the probability that the girls softball team or the girls lacrosse team will win today? I need the space, so I'm going to erase this and do the calculations up here. Alright, I'm going to highlight this to remind us that we are doing part C now. Okay, so the probability that a girls softball team, so that's C, or a girls lacrosse team, so we're talking about C or D. So, okay, the probability of C or D is going to equal the probability of C plus the probability of D minus the probability of C and D. Okay, now the probability of C is 80%. Probability of D is 60%. Now, the probability of C and D, if we do this like we did the last time, these should be independent. So, looking at our formula, okay, we just set up the yellow formula, but the probability of A and B, you multiply. So, it'll be the same thing, only with C's and D's. So, the probability of C and D is going to be 80% times 60%. In other words, 0.8 times 0.6. Okay, so let's see. 0.8 times 0.6, that's 0.48. Okay, so in other words, 48%. So we are going to subtract that 48%. So 80 plus 60 minus 48. That's 92%. Okay, so what's the probability that a girls team will win today? Well, 92%. Okay, because we just have the softball and lacrosse, and that's what we just calculated. Alright, so that brings us to part E. What's the probability that a boys team or a girls team will win today? Alright, it's going to be the same thing all over again. We're going to start off using the OR formula, alright, where we add but subtract the overlap. So, probability that boys or girls. This time I'll use B for boys and G for girls. Okay, so the probability of that a boys or girls will win, that's going to be the probability that boys will win plus the probability that girls will win minus the probability that boys and girls will win. Okay, so just like before, probability that boys will win, we calculated that at 80%. Probability that girls will win, we calculated that at 92%. Now, what do we do to find the probability that boys and girls will win? Well, we use this other formula, probability of A and B, you multiply. Okay, so this probability is going to be 80% times 92%. In other words, 0.8 times 0.92. Okay, that is 0.736, or moving the decimal point twice, that's 73.6%. Alright, it's a crazy 73.6%. What did I say at first? 0.736. Okay, so we'll go ahead and put that into the formula. 73.6%. Okay, so 80 plus 92 minus 73.6. That's 98.4%. It's a pretty good probability. Okay. So that's the probability that a boys team or a girls team will win today. So, which brings us to F. What is the probability that at least one team will win today? Well, again, that's just another way of asking the same thing. All right, if at least one team will win, that means, well, either a boys team or a girls team. So that is our 98.4%. Okay, fantastic. All right, that was a lot of calculation, but so we should be experts at that probability, at these, using these two probability formulas, because we just did it like three times in a row. Okay, number 8. The table below shows numbers of purchases in 3 stores and the corresponding gender of the customers for each number of purchases. What is the probability that a purchase is made by a male, given that the purchase is made in store B? Alright, you guys are experts at this, because by now you really understand that when they say given that, well, you just focus in on that and that becomes the whole universe for the rest of the problem. So given that a purchase is made in store B, so that means store B is now the universe. Whoa, why did it jump over there? Can I not do that? Yeah, like I said, store B, the universe. Okay, so we are going to absolutely ignore everything else. Okay, so store A, forget about it. Store C, don't even worry about it. Store B is the universe for the rest of the problem. Now, what are we supposed to find again? I got carried away. What's the probability that a purchase is made by a male? Okay, so males are 20 out of a total of, well, let's see here, 35. Okay, so 20 out of 35, because I'm just looking at my new universe. Both of these are divisible by 5. So if I do that, this will be 4/7. So that is the probability for number 8. Okay, moving on. A college admissions officer was curious about the major chosen by students at his college who had graduated from 3 high schools in a nearby city. He collected data on a sample of students from those high schools. The table shows the data. All right, what of it? The following probabilities apply to a randomly chosen student in the sample. Which probability is greatest? Okay, so this is what, multiple choice? So, yeah, I guess we just got to calculate all these probabilities and then we'll see which one was greatest. So, the probability that a student went to Central. All right. Now, it doesn't say given anything, so probability the student went to Central. Let's see, how many students went to Central? So Central is all of these. And that total is, let's see, 11, 12, 20. Okay, so you know what? We're going to have to add up all these numbers, so I'm going to do that off camera. Alright, well I found the totals, and first of all, the total number of students in question are 60. Total of 60 students altogether. Now, the probability of the student went to Central, well, 20 went to Central, okay, out of a total of 60. So that's 2/6, so that's 1/3. Alright, that's 33.33%. Excuse me, if you wanted it as a percent. Anyway, 1/3. Okay, fine. Well, you know what? That number might be useful for comparison. So, 1/3, which is 33.33%, by the way. Now, what's the probability that a student went to Western? Okay, here it comes. Given that a student is a computer science major. Okay, if they say given, whoa, I don't want to black it out. Given that she's a computer science major, okay, so that makes this my brand new universe for this question. Okay, which means for now, I'm going to ignore everything else. Okay, so now I go back and ask myself again, what am I being asked again? Let's see. Probability that a student went to Western. Okay, Western is this middle number. So that's 8 out of something. What's the total? Well, in this new smaller universe, the total is 20. So 8 out of 20. Alright, so 8 out of 20. That reduces, so that's 4. 4 divides into both of these, so that's 2/5. Okay, and 2/5 as a decimal is, let's see, 0.4. So that's 40%. Alright, so far B is winning because we wanted which probability is the greatest. So far probability B is the greatest. at 40%. But let's keep going. How about the probability that a student went to Eastern given that the student is a business major? Alright, got to start over with my highlighting. Okay, so this time we're given that the student is a business major. So I'm going to focus on business major as my new universe. Okay, that's my new universe. And with that in mind, I'm going to forget about the rest of this nonsense. Okay, so this is my universe now. Let's see, I'm going to switch back to blue. Now, what are we looking for? The probability that a student went to Eastern. Alright, well, Eastern is this number right here, 8. 8 out of a total of 25 in this smaller universe. Okay, so that's 8 out of 25. Okay, that's for this one. Let's see, 8 out of 25. That's 32%. Okay, that's the smallest yet, so B is still winning. Okay, last one. Probability that a student is a business major given that the student went to Western. Okay, so this time we're given something else. Given that the student went to Western. So this is what we're given. This is our new universe. Okay, which means we can forget about the rest of this for the remainder of this question. Okay, so what are they asking us for again? Alright, given that the student went to Western, what now? The probability that a student is a business major. Alright, well, this is the number that represents business major. Okay, so that's 6 out of something. Alright, 6 out of a total of 20. Alright, 20 students in this yellow universe. Okay, so that's going to be 3 out of 10 if I reduce, which is 30%. Whoa. Okay, that's the smallest one yet. So B is the answer with a 40% probability. Alright, and that's the end of this page. So that's going to be a good place to stop this video. This was part 3 of our probability review. We have one part left, one page left. And it looks like, taking a sneak peek here, in our 4th and final video, we'll get back into the Venn diagram and do some probabilities with that. And here come the cards, alright, deck of cards. Do some card probability. Alright, I will see you on the next video.